Hello friends, welcome to this next tutorial on maths for class 10th. We are doing real numbers, and in the previous video we had done Euclid's division lemma. Now let us see, in this video we'll try to cover the next topic, that is what is an algorithm and what is an lemma. So the definition of lemma is: a lemma is a proven statement used for proving another statement. That means lemma is a statement that is given by some mathematician and we need not prove that statement. We can use that lemma for proving some other statement or proving some other, it can be used in some other question. So it will be more clear when we go to the next step. Now let us see what is an algorithm. Algorithm is a series of well-defined steps. That means we have step number 1, we have step number 2, like that, which gives a procedure for solving a type of problem. So the algorithm tells us how to solve a problem, and it tells the different steps in an order that can be used to solve the question. Now let us see how we use a lemma and algorithm to solve a particular type of question. So to obtain the HCF of two positive integers, say c and d, if we have two integers c and d and they are positive integers with c greater than d, follow the steps below of Euclid's algorithm. So to find the HCF of two integers, we use Euclid's algorithm. Now Euclid's algorithm has many steps. The step number 1 is apply Euclid's division lemma. So we are using Euclid's division lemma here in step number 1 to c and d. So we apply Euclid's division lemma to step number 1 and to find the HCF of c and d. So if you remember what was Euclid's division lemma, it says that any two integers, positive integers c and d, can be expressed in this form. So let us apply Euclid's division lemma and we express c and d as c equals d multiplied by q plus r, where the value of r is greater than or equal to 0 but less than d. So this is how we apply Euclid's division lemma. This is step number 1. Step number 2. If r is equal to 0, that means r is the remainder. If it is 0, then d is the HCF of c and d. Then in step number 1, we directly get the value of the HCF. If r is not equal to 0, apply the division lemma to d and r. Then if r, the remainder, doesn't come to be 0, then again we apply the Euclid's division lemma, but in this case we apply it to d and the remainder r. Right? So let us take it, try to understand it by taking a small example. Suppose we have to find the Euclid's division lemma, the HCF for two positive integers. Say it is 14 and 7. Right? So we can write it like this: 14 equals 7 multiplied by 2 plus remainder 0. So 2 is the q in this case and r is equal to 0. So we have used Euclid's division lemma to write these two integers 14 and 7 in this form. Now you can see here r is equal to 0, the remainder, that is r, this is r, this is equal to 0. So in step number 1 it says if r is equal to 0, then d is the HCF. So we have remainder here equal to 0, that means the value of d, what is d? D is 7. So the HCF of these two integers will be equal to 7. So this is Euclid's division lemma in the first step that is used to find the HCF of two integers. Now let us take another example. For example, we have to find the HCF of two integers, that is 16 and 7. Now if we express it, we can express it like this. In Euclid's division lemma, 16 is equal to 7 multiplied by 2 plus it is 2 again. 7 multiplied by 2 is 14 plus 2, that is 16. So now in this case, this is R, 2 is R, this is R, and this is not equal to 0. So R in this case is not equal to 0. And what is Q? Q is 2 in this case. So if we go to step number 2, it says if R is not equal to 0, then apply the division lemma to D and R. So D is 7 and R is 2. So we apply the Euclid's division lemma to 7 and 2 in this case. So we can write it like this: 7 equals 2 multiplied by 3 plus 1. 2 times 3 is 6 plus 1. So again we get the remainder as 1. It is not equal to 0. So unless we get the remainder 0, we don't get the HCF. And we keep on applying Euclid's division lemma. So in this case, R is not equal to 0, R is equal to 1. D in this case is 2. So we again apply the Euclid's division lemma. Now in this step we apply it for D, that is 2, and R, that is 1. So we apply it for 2 and 1. So 2 equals 1 multiplied by 2 plus R, that is 0. Now in this case we are getting the remainder 0. So the very step where we get the remainder 0, in that step whatever is the value of D, that is the HCF. So here the D, that is divisor, is 1. So the HCF in this case will be 1. Highest common factor will be 1. Right? So this 1 is the HCF of the initial integers that we took, that is 14 and 7. So this 1 is the HCF of the initial integers that we took, that is 14 and 7. So in the step 3 it says continue the process till the remainder is 0. The divisor at this stage will be required HCF. So we continued the process, we continued applying Euclid's division lemma, and at last we get the remainder 0 here. So the HCF of the initial integers that we took, that is C and D, right? HCF of C and D is equal to HCF of D and R. That means HCF of, see now in step number 2 or step number 3 we find the, when we find the HCF, actually that HCF is the HCF of the divisor and the dividend in this case. So when we applied it here, 2 is equal to 1 into 2 plus 0. So in that case the HCF 1 was actually the HCF of this 2, that is the dividend, and this 2, that is the divisor, right? But simultaneously this 1 is also the HCF of the initial integers, that is C and D, that is 14 and 7. So indirectly it is an indirect method where we are finding the HCF of these two integers and they prove out to be the HCF of the initial integers, that is 14 and 7. You will be more clear with it when we apply it to some other examples. Now let us find the HCF of two numbers 4002 and 12008. So the greater integer here is 12008. So step number 1 is use Euclid's division lemma to write it in the form C is equal to dq plus r. So that is 12008 equals 4002 multiplied by q plus remainder r. So we need to find the value of q and r. So we can find it by dividing 12008 by 4002. So let us do that. 4002 and it's 12008. So as we can clearly see, if we multiply it by 3, it comes out to be 12006 and the remainder will be 2. So we have q equals 3 and r, that is remainder, equal to 2. So we can write it like this: 12008 equals 4002 multiplied by 3 plus remainder, that is 2. Now in step number 2, we check the value of r. If r is equal to 2, then that means it is not equal to 0. So we don't have the HCF yet. So again we will apply the Euclid's division lemma. But now in this case, we'll take the integers, this one, that is d, and this one, that is r. So now we have to write 4002 equals 2 multiplied by some integer plus remainder. So it would be 2001. If you multiply 2 by 2001, you get 4002, and the remainder would be 0 in that case. You can use the division, you can do the division to find this value of q and r in this case. So now this step gives the value of HCF, and the HCF in this case would be this number, the value of d. So this is the HCF, and this is the HCF of 4002. Sorry. This is the HCF of 4002, 2, and also it is the HCF of 4002, 12008. Finally, we needed to find the HCF of these two integers, and that comes out to be 2. Right? So I hope you are clear with the method of finding the HCF using Euclid's division algorithm. In the next video, we'll cover some more examples and exercise 1.1 of the NCERT book. If you like this video, please subscribe to my YouTube channel Learner Camp by following this link. Also, you can follow me on Facebook and Twitter for latest updates. Goodbye.